In this lesson, we are going to be talking about families of functions and the transformations that you can do to each one. So by the end of the lesson, you should be able to identify and describe transformations of linear, quadratic, and absolute value functions, and write the equations for each of those functions given their transformation. So now when we are talking about families of functions, family is just referring to the broad set of functions. So the three that we're going to be talking about, linear. So the parent function for that would be y equals x. Okay, the next family would be quadratics. So our parent function would be y equals x squared. And then our absolute value family, the parent function would be y equals the absolute value of x. So in just to review, remember a linear equation is a line. A quadratic equation is a U, or a parabola. And then the absolute value is a V shape. So the transformations from the previous section we talked about were reflections, vertical and horizontal translations. So when you move something up and down or to the left and right, and then a stretch or a compression. So we're going to discuss then the general equations. So for our linear, it would be y equals our mx plus b, so our slope-intercept form. For the quadratic, y equals a x minus h squared plus k. And then our absolute value, the general equation is y equals a absolute value of x minus h plus k. So on a linear function, when we are transforming it, the m, which is also like our a value, and our b is like our k value, the m is going to stretch or compress it. Okay, so remember for our stretch, a has to be greater than 1. And then the compression is between 0 and 1. And then if it's negative, it's going to be a reflection. And then this is going to move it up or down. Okay, up if it's positive, down if it's negative. So for our linear equation, we're not going to be moving it left or right because there's nothing inside the parentheses or absolute value sign with the x value. For quadratics, our a value is going to stretch or compress it. Okay, so again, it has to be greater than 1, and then compress is between 0 and 1. And then if it's negative, it's a reflection. Okay, our h value moves it left or right. So to move it left, it's positive. To move it right, it's negative. And then our k value moves it up or down. So up is positive, down is negative. Okay, so same idea with our absolute value. So our a is going to stretch or compress, and if it's negative, it's a reflection. Our h value is going to move it left or right. So left if it's positive, right if it's negative. And the k value is going to move it up or down. So for the quadratics, okay, the vertex for this, so the lowest point on that u is still going to be hk, and remember it's the opposite value of h. And then our vertex for an absolute value is also hk. So and this is where the starting point if you want to graph them. Alright, so let's move into some examples. So I'm just going to leave kind of those general equations up here as we're looking over this. So for the first set, we are identifying the transformations. So for that first problem, we have a linear equation. So the plus here is like our b value, so that's going to move it up or down. And since it's positive, we're going to move up 4. The second one, the squared here, tells us that we have a quadratic. So now we're looking at this set of equations. So the 2 here, that's our h value, and we are subtracting, so that means we're going to move to the right 2 spaces. And then the 3 on the outside, that's our k value. So since we're adding, we're going to be moving up. So the third example, okay, we're back to a linear function. So we're multiplying a number to x. So that's going to be like our a value, or m, for a linear function. And since it's less than 1, it's going to be a compression. Okay, so we're going to compress that by 1/2. Okay, the next one we have absolute value. So now we're over to this set of general equations. So the negative tells us that we have a reflection. There's nothing being added on the inside, so it's not going to move left or right. And then the negative 2 on the outside tells us it's going to go down 2. Right, another absolute value equation. The 2 on the outside is going to tell us that we have a stretch of 2. The 3 on the inside, that's going to be our h value, so it's going to move it left or right, and since we're adding, it's going to be to the left 3 spaces. Okay, and the last one for this set of examples, we have a quadratic again, and we can tell that by this power of 2 up here. So the 1/3, that tells us that we're going to have a compression. Okay, the plus 2 tells us we are going to move to the left 2. And then the 1 on the outside here tells us that we are going to move up 1. Okay, so that's just being able to identify the transformations of these various equations. Now the other thing that we have to be able to do is describe a transformation from a function to a function. So when we look at this next set of examples, we have to say how we went from this equation to this equation. So when we look at this, our 2 became a 1/3. So we have to think about how that happened. So to get a 1/3, I would have to divide this by 6. So I would end up with 2/6, which reduces down to that 1/3. So to go from this equation to this equation, for this part of it, I would have a compression. And then since I divided by 6, my compression would be by 1/6. Okay, now the other thing that I did is I added this 3 here. So that's going to move this equation up 3 spaces. So the other transformation would be up 3. Okay, for the next one, to go from this equation to this equation, when I look at it, I still have that 3x here. So on the outside of my set of parentheses, the negative tells us that we have a reflection. The 4 then is going to be a stretch. And then to figure out what this last piece did, we actually have to distribute that into our equation. So we would have negative 12x plus 4. So really I'm going to take this equation and I'm going to move it up 4 spaces. Now if you're having a hard time looking at this, remember you can always graph these sets of equations on your calculator and try and figure out the transformations from there. Alright, so for this last example, again, how do I go from this equation to this equation? So when I look at the inside here, I went from a -2 to a +1. So to do that, I would have had to add 3. So since I'm adding 3, we're going to be moving to the left. And then to go from a positive 3 to a negative 2, I would have to go down 5 spaces to get to that. So this would be moving down 5. Alright, so moving on. In this section, we also have to be able to write equations and describe their transformations. So when we look at problem 10, we have to write an equation for f of x, and then we have to write our equation for g of x, and decide what transformation happened from this line to this line. So if we start with f of x, we should be able to tell that this is going to be a linear set of equations. So that means we're going to be dealing with y equals mx plus b. So I want to find my y-intercept. So for f of x, okay, I'm looking at this line right here, my y-intercept is right at this point at 0, 3. So my intercept then would be a positive 3. Then I need to figure out my slope for that. So we just kind of want to go here and find where it crosses another point nicely. So here it looks like it's going through this perfectly, so I'm just going to use that to figure out my slope. So from this point I would go down 1, 2, 3, and then over 1, 2, 3, 4. So my slope then would be a negative 3 since we went down, and then to the right 4. So now I should be able to write my equation. So f of x equals negative 3/4 x plus 3. So now for g of x, I go through and I do that same process. So I want to find my y-intercept. So it looks like it's going to be right here. So this would be at 0, negative 3. And then I also need to go through and find the slope. So I'm just going to use this point again since that's where it's crossing nicely. So this time I would have to go up, so 1, 2, 3, and then over 1, 2, 3, 4. So this time my slope is a positive 3/4. So when I write my equation, I would have 3/4 x minus 3. So now when we're looking at how we go from this equation to this equation, if you notice that the signs on each of the numbers switched, so basically I can factor out a negative 1 from this one. So 3/4 x minus 3. So when you can do that, that means that a reflection happened. On the next example, since we have the U shape, that tells us that we have a quadratic set of equations. So we are looking at our general function y equals a absolute value of x minus h plus k. So now when we're writing these equations, we have to figure out our h, k, and a value, since those are just our numbers. So we're still going to follow the same steps that we would for writing an equation for an absolute value because it's the same idea. So if I start with f of x, I just need to figure out that vertex point. So it looks like it's going to be at 1, 2, 3, 4, so negative 4, 0. Okay, so vertex is at negative 4, 0. And then I'm going to need to find another point on that to get an x and y value. So if I just use this one, this would be at 1, 2, 3, negative 3, positive 1. And I just substitute all of that into the general equation to find that a value. So y, I would get from my point. So 1 equals, I don't know what the a value is. And then x comes from the point, so negative 3. And then minus a negative 4, so that would be plus 4. And then plus 0 on the outside. So now I just go through and I solve for a. So I have 1 equals, and then this would just become a positive 1. So a is 1. So for f of x then, our equation would be x plus 4 squared. Okay, now I go through that same process to write that equation for g of x. So I need to find that vertex, which is going to be at -2, let's see, 1, 2, 3, 4. So -2, -4. Okay, then I go through and I figure out the point. So this one's going to be at -1, -3. And again, the point that you use on this line doesn't matter. It just has to be one that you can find easily, and they've highlighted these points. So I could use either one of those. So now I plug this information into my general equation. So y, so -3 equals a, oops, and then x, which is -1, minus a +2, so that becomes +2, and then -4 on the outside. Oops. These should have been parentheses squared. Alright, so now when we simplify, I would have -3 equals, and then -1 plus 2 is 1, 1 squared is 1, so just a minus 4. Then we would add 4 to both sides. So 1 is going to equal a. So now I can write my equation. So g of x equals, and then it's going to be x plus 2 minus 4. So to describe the transformations, to go from a +4 to a +2, I would have to go down 2. And then since I'm just adding 0 on the outside, so to go from 0 to a -4, I would have to go, sorry, I said this backwards. There shouldn't be a down. There should be a left or a right since we're dealing with h. So to go from a +4 to a +2, we have to go to the right. So this should be right 2. The other way that you can do it is if you go from vertex point to vertex point, you should be able to figure that out. So our a values have to be the same to do this, and they are. So I would end up going down 4 and then over 2. So that's another way that you can figure out your transformations. And the last thing that we have to be able to do from this section is be able to write equations given the transformations. So for this one, we're using the parent function. So this is our quadratic. So here's telling us that we are going to do a compression of 1/2. So when I write my equation, it would just be f of x equals 1/2 x squared. Okay, for the next one, left 2, so that's inside the set of parentheses for the general equation. So it would look like y equals, and then x plus 2, since we're going to the left, squared. Or if you still want to be in function notation, it would just be f of x equals x plus 2 squared. Okay, a reflection that tells us that we're going to be opening down, so we need a negative out front. And then since we're going down 1, we would subtract that on the outside. So f of x equals a negative x squared, and then minus 1.